Okay, this is the video for section 7.1, Math 800. We're going to start talking about factoring in chapter 7. So this first section is all about factoring by using the greatest common factor. And that is going to be really important because no matter what other methods we use for factoring, you always have to come back and do this one first before you do the others. And we'll talk about that more. We'll talk about it in every section. So you really have to get this section down. Wow. There are three things we're going to talk about. The first is kind of what is a greatest common factor and how do you just find a greatest common factor. The other is to use that greatest common factor to factor polynomials. And the other is factoring by grouping, which uses kind of a greatest common factor. So here's kind of a procedure for looking at any finding greatest common factor when you have a list of terms. So it can be numbers, it can be monomials, it can be 2 things, it can be 5 things, it can be however many things, okay? It doesn't matter, but you are going to factor each one of those terms and then, just like it sounds, figure out the things they have in common. Okay? So, for example, here we have the 3 numbers, 30, 45, and 75. So we want to know all the factors of these. And probably the best way to think about this is using a tree. Just a second, let me get my pen working. Okay, so 30 is 3 times 10. Now 10 is prime, so we'll be done. Or sorry, 3 is prime, so we're done with 3. 10, we keep going, is 2 and 5. So we end up with 2 times 3 times 5. All right, 45 is 5 times 9. 5 is prime, so we're done there. 9 is 3 times 3. So we have 3 times 3 times 5, or sometimes we write it 3 squared times 5. All right, and then we have 75. That is going to be 3 times 25. That's the one I know. 3 is already done. And 25 is 5 times 5. So you've probably done these trees before, but you're always trying to get every branch down to a prime number. And when you do, that prime number becomes part of your primes. So this one is going to be 3 times 5 squared. So now we look at these 3 prime factorizations and find the things that they have in common. Okay, so this first one has a 2, but none of the rest of them have a 2, so that's not in common. But they all have a 3, and so a 3 is going to be one of the factors. And this one actually has 2, but these two only have 1. So we can only take 1 3. And then the next factor is in common is a 5. And we can look here. We have 1 5 here. We have 1 5 here. We do have 2 5s here, but it has to be how many they have in common. So just 5. So that equals 15. So 15 is our greatest common factor. I know that I had some things, but I did all the same thing. If by chance they didn't have any factors in common, the greatest common factor would be 1. All right, so here's one that has variables with it. So you still look at the numbers the same way. We look at all the factors, and we see that, so 20 x to the fourth y, if we factor that 20, that's going to be our 2 squared and 5, right? And then we have x to the fourth and we have y. So all of those things are factors. The 15x cubed y gives us a 3 times 5. And then the 10 x to the fifth y squared gives us 2 times 5 times x to the fifth and y. So first let's think about the numbers. What factors do they have in common? 2 of them have 2's in them, but the third one doesn't, right? To be in common, it has to be in all of them. So 2 doesn't work, 3 doesn't work, but 5. 5 is in common with all 3, right? So 5 will be part of our answer. Then we look at the x's. They all have some x's, right? Now, how many x's are in common? So remember that the x's are, this is like x times x times x times x, right? 4 of them in the first one, 3 of them in the second one, 5 of them in the third one. So we take out the most we can take out that's true for all of them, right? So that's actually the one with the lowest number, the 3, right? All of them have at least 3 x's. So x cubed will be our x. And then in the y's, they all have a y. The first two only have 1 y. The third one has 2, but we can only take as many as they all have. So it's just y to the first power. And that is our greatest common factor. Okay, so that's finding the greatest common factor. Now, I want you to think back to what we were doing a few sections ago. We were multiplying, right? And we distributed. So if you were going to distribute this, remember that we take it and we distribute it to each thing, right? We have 2x times 3x, and then we'd have minus 2x times 4, right? So do you see how that 2x is in both of them? Right, that means that if we were going backwards, that would be a common factor, right? So when you're working with a polynomial, when you're trying to factor out the greatest common factor, it's kind of like undistributing, right? We will undistribute. I forgot I had something coming up there. But we can undistribute, right? So we have to figure out if we were going the other way. We were going the other way and we were looking at, so we forget this for a minute and we start with this one, because that's what we're going to do, is we're going to go backwards. We start with this and we say, what is the greatest common factor that these two have in common? Well, in 6 and in 8, the common factor is a 2. So we have a 2. And then the x's, we have an x squared and an x. So the common one is x. That's the most we have, right? And we factor it out. We undistribute it, right? So I have to figure out, what did I multiply 2x by to get 6x squared? Well, if you're having trouble figuring that out, you actually can divide it, right? We learned that dividing by a monomial, and I would cancel the 6 over 2 is going to be a 3, and x squared over x is going to be an x. And I would do that here too. The 8 over 2 is going to be a 4, and x over x is just 1, right? So this would be it all factored out. Okay, so do you see how it's kind of that undistributing? Okay, so we want to do that. We're going to do several problems here where we're going to factor by pulling out the greatest common factor. So we look at here, we can look here and think, well, there's only one variable, so there's not a variable in common. It's just going to be in the numbers, right? And 6 is 2 times 3, and 30 is 5 times 6, and 6 of course is 2 times 3, but actually once I found that 6, that would be all I needed, right? So 6 is in common. So I pull that out, and what's left? The n plus, and what do I have left when I take out the 6 out of 30? Well, if I did 30 divided by 6, that would be a 5, right? So the nice thing about factoring is you can always check your work by multiplying. Since factoring is kind of unmultiplying it, right? You can always multiply it back out and see if you get the same answers you started with. And sure enough, if I distributed, I would have this 6 times n, that would be 6n. And I would have 6 times 5, that would be the 30. And that gets me back to where I started. All right, so here's our next problem. Let me erase some of my marks here that I have in the way. All right, so now what's in common between x cubed and x? Well, there's no number, so it's all down to the variables, and we just are going to pull out an x. And one of the ways to think about that, so when I pull out an x, remember, I can think about dividing. So if I have x cubed divided by x, that'd be x squared, and x divided by x is 1, right? So that's why when we are looking at this solution, we end up with the x, that's sorry, come on, let's make my screen mess up. Since this is one of the ways to think about it, is since there's just an x, we can think about it as x times 1. So when we pull out that common x, we have to end up with 1. Now, as you recall, when I just showed you, you could figure out what those numbers are by dividing, and you get a 1, right? When you divide x divided by x, that is 1. All right, so here's one more. This time, I want you to see if you can figure out the greatest common factor and factor it out. See if you can figure out what will be left inside the parentheses when we factor out that greatest common factor. So go ahead and pause the video if you need a little bit of time and figure out what that is, the greatest common factor, and then do the factoring out. Okay, hopefully you found it. The greatest common factor, I hope you all found, is going to be 5x squared. Since this is a 5 and 1, right? Just we're thinking about it as a 5, and this is a 5 and 3. Okay, and then the x squared is the common factor here because it's the most, they both have x's, and x squared is the most that is in both of them, right? All right, so when we pull it out, you should have had 5x squared times x minus 3. Okay, so in this one, we have a trinomial, right? But we're still finding the greatest common factor of the polynomial. And we look here, they don't all have x's. Oops. The last term does not have an x. This term does not have an x in it, right? So it's just down to the numbers. But the first two are 2's, but this one is a 3, and there's nothing in common between 2 and 3. So there are no, the greatest common factor is a 1. Okay, that's what that means. The greatest common factor is a 1. And you can't really factor it out. It's no common, there's nothing else, so it is itself. Factoring out a greatest common factor is just like multiplying it by 1. All right, now here's another one. This is another trinomial, but this time there are some numbers in common. So, take a minute and find the greatest common factor of these terms in the polynomial and see if you can factor it out. There's actually 2 ways to factor this or to think about this, okay? I hope you found that a greatest common factor would be 2a squared. And if you factor that out, you end up with negative 2a cubed plus a minus 3, right? And you can always check it. Remember, you can check it by distributing. Okay, so if you distribute it back out, you got back to what you started with, then that was right. But one of the problems that we run into here is that this negative right here, that's going to cause us problems in the next step that we do in the next section. That we kind of want that negative to be a positive. So if it begins with a negative number, like it does here, right? It begins with this negative number. We really want to include the negative in the greatest common factor. Okay? So you could factor this like this, right? So instead of the greatest common factor being 2a squared, it's negative 2a squared. Now, how do we figure out these terms if you've got an extra negative? Just remember that when you divide by negative 2a squared, the negatives will cancel each other out, right? And that becomes a positive 4 over 2, which is 2. And then a to the 5th over a squared is a cubed. And this one will divide by a negative 2a squared. Well, that means I've got a positive 2 over a negative 2, which is negative 1. And that's why we end up with a negative over here. Right? And then when we do a negative 2a squared here, the two negatives cancel each other out and we end up with a positive. So it gives you kind of the opposite sign from what you started with when you pull out a negative. But remember that if you multiplied it back in, you could double check and make sure you got those signs correct. Okay, so this is the way normally we would want to factor it. We want to do a negative because we want, when you end up with this trinomial here, we want to have a positive number on this to start with. And I'll show you more about that in the next section when we have to factor out some greatest common factors from a trinomial, and we'll want to have it positive in order to do the other things we're going to do with it. Okay, so these are just some more. I want you to try to do these more on your own. I'm going to give you a second. You pause the video if you need to, see if you can do it, and then I'll show you the answer. We'll just be looking at a couple of little things that cause people to make mistakes. Okay? All right, so here's the first one. Pause the video, see if you can find the greatest common factor and factor it out. Okay, here's the solution. So this 4ax was definitely the one, and you notice, I think we talked about this before, when you factor this out, the thing you have left has to have just as many terms as you started with. So this has 2 terms, this has to have 2 terms. Every term has to be represented here, because when I multiply it back out, it has to get me back to where I started, right? So even though it looks like I'm taking the whole 4ax, it's not a 0 that's left, it's a 1, because you divide. And if you think about this as dividing 4ax out, then it helps you remember that that's left as a 1. Okay, here's the next one. See if you can figure out the greatest common factor and write it factored. Okay, hopefully you found it. The greatest common factor will be 3xy squared, and we end up with x minus 2. All right. Seems like it's getting a little more complicated. We have more than one variable this time, but it's still the same. Just like we were finding greatest common factors, we had more than one variable. So find the greatest common factor and factor it out. Remember that what's left in the parentheses has to have 3 terms, because this one has 3 terms. Okay, hopefully you are able to do it. We want to factor out the negative, remember, because this had a negative here. So we factor that negative out. That's going to change all these signs. That means this one is negative here, so it will be positive here. This one is positive here, so it will be negative here. Okay, here's another one. Factor those out, find the greatest common factor, and factor it out. And here's our solution. Hopefully you found the a squared b cubed. So these are a lot of b's here, right? And a lot of a's, but the smallest exponent on the a's is an a squared. And so that is the one that's common. And the smallest of the b's is b cubed, so that is the one that's common. And we end up with 3 terms left, right? So now, these are some, you might think to yourself, well, let's distribute that, right? But we don't want to distribute yet. It's almost factored, right? We have a common factor. So think about this in terms of this is one term and this is one term. And in these factors we have a 3 and x squared, and we have this 5x plus 1. It's all one factor. Here we have a 2 and a 5x plus 1. All one factor. That 5x plus 1 is a factor because it's multiplied. So since we are factoring the greatest common factor, that 5x plus 1, that is a common factor. Okay, and so since it's a common factor, we can factor it out, right? And the way we would figure out what's left, is by dividing, right? So if we divide 5x plus 1, these two will cancel, right? And we'll be left with just the 3x squared. And here's how the solution looks is we pull out that 5x plus 1, and we end up with the 3x squared minus 2. So this is one factor. This is one factor. And then this whole thing would be distributed in to those two. Okay, so here's one more of those. So this is on your paper, so see if you can factor out that 2x minus 3, remembering that you're going to end up with two terms, right, when you factor it out, because there's two terms here, and one of them is not 0. If you think about it as dividing, that will help you. Okay, hopefully you found that. Here's the solution, and notice that we think about this as 2x minus 3 times 1. Sorry, I messed up my screen. There we go. So this is our answer, all factored, right? Here it is. You notice it's two binomials, right? It is two binomials, and one of them was that common factor that we had, but the other one is what's left. And if you multiplied this out like we learned how to do in chapter 6, it would be equal to the thing we started with if we multiplied that all out. Okay, so we're going to come back to this. We're going to use this as we do some other factorings, but this is kind of the main thing that we wanted to talk about in this section. This is the first time we're really going to do some actual factoring other than greatest common factor. Now, here's the deal, is we always look for greatest common factor first. But this factoring by grouping is the first way that we do factoring. If this is the only way that we know how to do factoring if there are 4 terms. Okay, we'll learn some other ways to do it if there are 3 or 2 terms, but if there are 4 terms, it's got to work by grouping or we don't know how to do it. Okay, so I'm going to show you 2 ways. Okay, so the book only tells you the second way. So if you go back to the book to look through it, you'll do it by grouping, and you may already know how to do it by grouping. But remember how I told you I wanted you to do some multiplying with the box? That's because of this, right? I want to show you how to use the box to factor. Okay, so remember that when we multiplied with the box, we had, terms up here and terms over here, and we multiplied these together, and we got, this, right? And then we could add them up, add like terms, but we took the factors and we got the answer. Well, factoring now is unmultiplying, right? So what we have here is the answer. Oh my goodness, I'm sorry. Okay, this is not working well. So I'm going to put those 4 terms in here. Now, sometimes it matters the order. Usually, so it's not always just one way that you can put it in here. Oftentimes they're already in order, and most of the times when we use this, it'll be fine in order. But if it's not in order, what you'd be looking for is that these first 2 have something in common. Okay? So the thing that they have in common is an x. So that's the greatest common factor of just those first 2. And then we're going to put on the outside the thing that we would have to multiply by to get that answer, right? So this has to be a y, because x times y would give me that xy. And x times 5 would have to give me 5x. So this has to be a 5. And then y times something is going to equal this 3y, so this has to be a 3. Now, the last one we double check, because if it doesn't work, then we can't, it's not going to factor, right? So 3 times 5, that equals 15. So it all works, right? So our factors are x plus 3 and y plus 5. Now, it doesn't matter which order I write them in. Remember, multiplication is commutative. So if you write your answer y plus 5 times x plus 3, that's perfectly fine. Okay, now, so that we call this factoring by grouping. And typically, the book is going to refer to factoring by grouping as the way I'm going to show you now. And in case you don't like the box, if you really hate the box, you can do it this other way. But I am telling you that the box actually is really nice, and it gets you out of trouble in a few places. But I'll show you those as we come to them. Seriously. Okay, so when you're doing it by grouping, you separate the two parts, okay? I actually prefer not to use parentheses, but you can if you're careful about this. If this is a minus sign, it's got to go in here with the other stuff, right? And you got to make sure you put that plus there, because some people leave it out. All right, and then we pull out the greatest common factor of each of those sets separately, just like we did in the box when we did the top row and the bottom row separately, right? So I pull out the greatest common factor of the first two, and of these two, and it's an x. That's all they have in common, right? And out of the second two, a 3 is all they have in common. But what was left, this x plus 5, they're both the same, and that's the key. If they're both the same, it's going to work. Okay, so then you pull that one out, and what's left is the x plus 3. So you're pulling it out just like we did on those ones where we pulled out that common binomial. So if you don't get the common binomial, then you're kind of stuck with this method, right? Or the other one. If you can't pull anything out in the box either, it's not going to work. Okay, so let's try another one. All right, so I want you to try it first with the box. So just to try, find a box, write the box, fill in all those 4 terms, and see if you can get the factors using the box. If you're wondering if you did it right, then multiply the 2 factors you got as your answers together and see if you get what you started with. Okay, so hopefully you filled in your box. So x squared is going to be just x and x, right? There's no other way around that one. So to get this one over here, we have an x, so we need a negative and a y, right? So this would be negative y. And down here, we have a negative 5x, so we have the x, we need the negative 5. And then double check, negative 5 times negative y will give me positive 5y. So my answer is x minus y and x minus 5. All right, so we'll just look and see how we did this with the regular grouping way. So here's one of the things that we ran into trouble. And again, it came down to this thing that we did before. When we we're looking for the greatest common factor here, and we factor out a 5, then what you end up in here is not, this is not equal to this, right? But had we factored out a -5 and made this first term positive, like this one is positive, since we're trying to match them, right? When we factor out a -5, then it does work out, right? So here's where if we factor out the -5, we do end up with the 2 the same. So yes, we can finish factoring, and that was success. You notice that I didn't have that problem when I did it with the box. I didn't have to think about it or worry about it. It just took care of it by the way I was figuring out the box. Just saying. Okay, here's another one. You can try either method you want. I'm sure you figured out by now which way I prefer. If you are having trouble with the grouping method, writing it all out in an algebraic statement and manipulating it, then try the box. So go ahead, pause the video, and go try it. Okay, I'm going to show you first with the box. Fill in all these 4 terms. Then I'm just going to go across the top. I'm going to pull out the common factor, which is x. This is going to be an x as well, since it has to be x times x is x squared. This has to be an a. Right, now I have an x here, so this has to be a 3. And 3 times a is not 3y. What happened? There isn't any way that y is not anywhere else. So there's not going to be a way to factor this. It's not going to work. So this cannot be factored. That's how you find out that it can't be factored when you're using the box. So let's look at how you find out it can't be factored when you do it the other method, right? When you look at these two things, right? So we look at this, we look at this, we factor out the greatest common factor, and look, these are not the same. There's no way for us to have manipulated this. Sometimes we can rearrange this equation, but there's just no way to do that because there aren't other y's or a's, okay? It is not factorable. Okay, try this one. Okay, let's look at what we have. When we do Alright, so if we multiply out a common term, or we pull out the common term here is x, here will be a y, which means this has to be a 1, and x times 5x, that's going to be 5, and so 5 times 1 is 5, so it worked. Y plus 5 and x plus 1. Alright. Let's see how it looks with the solution. Got the same answer, right? Okay, here's one more. See what we can do with this. This one has a slight complication with this one, but we'll see how it works out. Okay, so when we put these in here, sorry, oops, that's a negative. Should have put that inside the box. Okay, Sorry, my handwriting's getting worse. This stylus drags everything together. Okay, so we're looking for the greatest common factor. Well, first of all, these two right here, they have nothing in common. Not a single thing, right? I can't pull anything out. I really have to have one of these variables. I got a lot of variables here, and I really have to have something to pull out. Now, these two have something in common. I could pull a y out, right? But these two do not. And so the first thing I would want to try before I give up is I want to try just rearranging a little bit. So if I have my 5, what is that? 5xy. Here, I want to have something in common. Now, so I either want this 3vy or the negative 10ux to be next. So the 10, that's, I'm going to put this one here because the other one I can put. So this has a number, the 5 as well as the x is in common. The other one, the one with the y in it, I will put down here so that I would have a common y as well, right? So that leaves me with this one, which I'm going to put over here. Now, it still might not work, but if it doesn't work now, it will be because it's not factorable. All right, so I'm going to look across the top and say, what's the common factors? I got a 5, and I have an x. So up here, I've got to have a y. Now, on this one, something I got to multiply by 5x to get negative 10ux. So I need to pull 5x out of here, right? So I would have negative 2, and the x is gone, so I just have negative 2 and u. So if you're struggling with how to figure out what goes up there, then you would take that and divide, right? So the 10 over 5 is 2. It's negative 2. The x's cancel, and I just have left the u. So that's how I get that negative 2u. Now, I have a y here, so from this negative 3vy, I need everything else besides the y. So this is going to be negative 3v. So here's the big test. We've got to multiply these together and see if we get the last number. But we have negative 3v, negative 2u. So multiply the negative 2 and the negative 3, and we get that positive 6. And we have a u and a v. So it worked. This factors to be y minus 2u and 5x minus 3v. Okay, so when we're doing it with grouping on a line with an algebraically, we still notice when we're trying to when we're trying to do it, we notice there's no common term. And so that's why we would still rearrange. Now, how you rearrange, there's different ways. They rearranged by putting that negative 3vy here. That's perfectly fine. And then we can go ahead and group. But you need to have something in common. And it worked the same, right? We didn't, in the one we just did in the box, we were factoring an x out first, but that's okay. The x is going to be in the one that's left, right? The x is going to be in here. Now, here's the other issue we end up with. These two aren't exactly the same. Now, we know it factored. It worked before, right? But these are not exactly the same. This is 5x minus 3v, and this is 3v minus 5x. They're almost the same, but they're opposite signs. In this one, the 5x is positive. In this one, the 5x is negative, right? In this one, the negative 3v is negative 3v. This one is positive 3v. So all I needed to factor out another negative. And changing the order of these, if I just changed this order, which is perfectly allowable, if I have the negative 10ux and then the 6, then I would have known to factor out the negative. And so if I factor out that additional negative, then it turns out just fine. Right? Because even though they look a little bit different here, they're really the same, right? Okay, can you see we didn't have a problem when we did the box? All right, these are the practice problems. Pause the video and try factoring these 7 problems. The first 4 are just factoring out the greatest common factor, and then the last 3 are actually doing it by grouping. And now actually, that's not true either. 6 is also factoring by grouping. So 5 and 7 are the only ones we're factoring. No, that's not true either. See? All the first 6 are factoring out the greatest common factor, including as a binomial. It's only one of them that you have to do the box or the other method of grouping. So, all right, so hopefully you got those since you're back. So here are the answers. If you have any problem with this section, please talk to us at our class meeting. This is a really important thing to be able to do. This, not only the grouping, we're going to do grouping again in another one, but also the greatest common factor factoring. And in all of these, especially the ones that turn out to be 2, when it turns out to be 2 binomials, you could have them in the opposite order and it would still be correct, right? You could have x plus 7 times 5 minus y, and that would still be perfectly good. All right, we'll see you later.